This video is going to get us through the chemistry lab worksheets that I have posted in Blackboard for you guys. One of the things that I would recommend that you have available is a printed out periodic table. You can find them online really easily. This is just one example of a periodic table that I happen to have a copy of, but there's a bazillion of them all over the place. Starting on page 1 of the lab worksheets, it just talks about the subatomic particles that make up an atom. So you've got 3 options: protons, neutrons, and electrons. Protons have a positive charge, neutrons have no charge. Both of those 2 subatomic particles weigh 1 atomic mass unit, and so both of those contribute to the atomic mass that an atom is going to have, and they can again be found in the nucleus. The electrons have a negative charge. They can be found in orbitals outside of the nucleus. Now, if we go to page 2, first thing they give you is a little drawing of an atom up here. The little positives are protons. They're kind of hard to see in my black and white drawing, but there's some neutrons that are present. So this is the nucleus of the atom. The electrons can be found outside of the nucleus in what is realistically a cloud. We never really know where the electrons are, but we usually draw them on these concentric rings that are called orbitals. And those orbitals can each hold a set number of electrons. The first orbital can hold 2 electrons, the next one out can hold 8, the next one out can hold 8. That's as high as we're going to get in biology, by the way. Now, if you were to be presented with a drawing of an atom that looked like this, there's certain information that you should be able to deduce from that drawing. First definition that I want to give you here is something called the atomic number. The atomic number is defined as the number of protons present in the nucleus. And so as you look at this drawing, there's 3 protons in there. So we can write the atomic number down. And then that number actually tells us the identity of the atom. So if we come back and we look at a periodic table that we happen to print off, you can find the one that has the atomic number 3. And now you know that that atom that's drawn out there, it's a lithium atom. So you can write the atomic symbol to the right of that atomic number. Next thing that you can figure out is what's known as atomic mass or mass number. That's the number of particles that are present inside of the nucleus, protons and neutrons. And so you just add them up. So there's 3 protons and there's 4 neutrons. So 3 plus 4 tells us that the mass number is 7. The atomic number is written to the lower left of the atomic symbol. The mass number is written to the upper left of the atomic symbol. So from that drawing, I was able to get all of the information that's essentially present on the periodic table. Now, a little side note, that atomic number, while it is defined as the number of protons present in the nucleus, if you have an electrically neutral atom, it's going to have the same number of electrons circling in orbitals as protons inside the nucleus. So there were 3 protons, there's going to be 3 electrons outside. That holds true unless you have ions, which are charged particles. Those have different numbers of protons and electrons. That's something we'll talk about again when we get to lecture. But we could figure all of that out based on that drawing. Next, if they were to give you something like that, you should be able to draw the atom based on the information that's provided for you. Now, if you pull most periodic tables off the internet, this tends to be the format that they have them, but that's not always the case. Now, here's what I mean by that. In this particular block, they put the atomic number above the symbol and then the atomic mass below it. On this periodic table, they put the atomic number where I told you should be writing it, which is to the lower left of the atomic symbol. And then they put the atomic weight, which is similar to mass, but not exactly the same thing. They put it to the upper left of the atomic symbol. So the way that you would be able to figure out, if you didn't know where stuff on your periodic table was, the atomic number has to be a whole number because you can't have part of a proton. And so just look for the whole number. That's got to be the atomic number. Look for the number that has decimal points after it, and that's going to be the atomic weight. If you want to try to turn that into a mass number or an atomic mass, just round that off to the nearest whole number. But that's how you're going to figure out what's the number and what's the mass, no matter which periodic table you have to be looking at. Now, coming back to this, if they were to give you something like this, you should be able to tell me how many protons, neutrons, and electrons that atom is going to have in it. Since the atomic number is defined as the number of protons, we know that there's going to be 2 protons present inside the nucleus of the atom. Next, we're going to come over here to the mass number. So helium has a mass number of 4. That's how many particles are present in the nucleus, and we know that 2 of those are going to be protons. That means the other 2, to get us to 4, that's going to be neutrons. And so we're going to draw 2 neutrons. So 2 plus 2 gets us to 4 for the mass number off over there. Now, if the atomic number tells us there's 2 protons, as long as we're electrically neutral, which we are because there's no pluses or minuses up here, then we know there's going to be 2 electrons floating around outside of that as well. And so we're going to go ahead and doodle 2 little electrons floating outside of that. So we were able to deduce the whole atom just based on the information that's provided there. There's lots of videos that you can find online for this stuff. One of the ones that I usually show when we meet for face-to-face classes, you can search for it on YouTube. It's called Dogs Teaching Chemistry, the Atom. And so they explain all of this stuff again to you. I recommend that you watch it if this is confusing you at any point. Okay, so next they give you this. They want you to label some of the stuff that we were talking about earlier. So if it has a positive charge, it has to be a proton. If it's in the nucleus and it doesn't have a charge, it's a neutron. This one, don't worry about it. We're not talking about the things that make up the subatomic particles. The negative right here means that this is an electron. And all the stuff in the center makes up the nucleus. They didn't point to this, but I would go ahead and label that ring as an orbital or a shell, or sometimes an energy level, but that's where you're going to be finding those electrons. Next, fill in the blanks. What part of an atom has no charge? I'm going to start abbreviating here. Neutrons have no charge. What part has a positive charge? Protons. What part has a negative charge? Electrons. Blank and blank. There are the same number of these 2 particles in an atom. Protons and electrons, those are going to be the same. You can have different numbers of neutrons and it doesn't affect the identity of an atom or the charge of an atom, but you do have to have the same number of protons and electrons. Otherwise, it's not technically an atom anymore. It's an ion at that point. The atomic number is the same as the number of these particles. That's protons. Blank and blank, the mass number is determined by which 2 particles. That would be protons and neutrons are what make up the mass of an atom. Next, they give you a bunch of questions that honestly end up getting really repetitive. They're asking you the same stuff, only now it's multiple choice. So negatively charged electrons, positively charged protons, nucleus and no charge, neutron. Charge and mass of a proton on an electron has the opposite charge and a smaller mass. So it's this one. Once again, positive is proton, negative is electron. See what I'm saying? They get super repetitive through here. Where in an atom are the neutrons located? In the nucleus. If an atom has an atomic weight of 39 and an atomic number of 19, how many protons does it have? They're really good at asking this type of question where they're giving you actually more information than you need. That tends to make students think they have to do stuff they don't have to do. But here's what you need to remember. The atomic number is the number of protons, and so it's going to have 19 protons. Use the following information for questions 9, 10, and 11. If an atom has an atomic weight of 45 and an atomic number of 21. Okay, so remember, atomic number tells you the number of protons, always. Okay, 2 of these questions ask the same thing, so I'm going to cross the neutrons off here, and we'll ask about protons in the first one. And I don't know, maybe yours was already corrected online, I'm not sure, but how many protons does it have? Well, if the atomic number is 21, it's going to have 21 of those. If it's got 21 protons, it's got to have 21 electrons, unless it's an ion, which this does not say it's an ion. Now, this is the one that you have to do some math on to figure out the number of neutrons. To do the math for the number of neutrons, you do the atomic weight, and then you subtract the atomic number from that. And so there's going to be 24 neutrons present inside of that. All right, same stuff, just different atoms. So atomic number is 24. They once again ask the same thing twice. So this time I'm going to change this bottom one. The number of protons is going to be 24. Electrons is going to be equal. We got to do that math. So it's the atomic weight minus the atomic number. I'll even do it all old school for you guys. So let's see, carry the 1, 12, 8. This is going to be a 4 at that point. So 28 neutrons present inside of that. You're always welcome to use a calculator. All right. You guys try to do those on your own. If you have any questions about those, just email me and I'll let you know what's going on. I'm going to skip down to the table down here. This one, they're giving you a couple of pieces of information. The periodic table might be helpful for you as well as you answer some of this stuff. but we'll just do it based on the table to start us out. So carbon has a mass number of 12 is what they're telling us. What's the atomic number? You really do have to look at the periodic table to figure that out. So carbon has an atomic number of 6, which means it has 6 protons. If the mass number is 12, 12 minus 6 tells us it's also going to have 6 neutrons. Next, they tell us something has the atomic number of 8. So we've got to look in the periodic table to figure out what that is. 8 is oxygen. So we can write oxygen or just write the atomic symbol in there if you want to be lazy. The atomic number is the number of protons. If it has 8 neutrons, 8 protons plus 8 neutrons means it's going to have a mass number of 16. The element that has an atomic number of 11, looking that up on the periodic table, that is sodium. This time I am going to be lazy and I'm just going to write the atomic symbol like so. It's going to have 11 protons. This time they didn't give you either the mass number or the number of neutrons, so we're going to look that up on the periodic table. The mass number is the atomic weight rounded to the nearest whole number. So 22.9 is going to round up to 23. We'll write 23 right here. Now we have to do the math again. 23 minus 11 means that there's going to be 12 neutrons present inside the nucleus of a standard sodium atom. How are the atomic number and the number of protons related? They equal each other. How do the number of protons and neutrons and the mass number relate to each other? So protons plus neutrons equals the mass number. What is the one thing that determines the identity of an atom? That's the atomic number. If you know the atomic number, you can figure out everything else from the periodic table. Okay, after that, we take the next step and we go back to electrons can be found in orbitals, but each orbital can only hold a set number of electrons. They went ahead and told you how many each one can hold, but what I would recommend that you do is a doodle. We're going to need 3 concentric rings. Whenever you start placing electrons, you start in the innermost circle closest to the nucleus. That one can hold up to 2 electrons. If an atom has more than that, you fill this one and then you move out to the next one. The second orbital can hold up to 8 electrons. Now, if the atom has more than 10 electrons, after you fill those 2, you move out to the next one, and you would keep doing that. But for our purposes, that third one out can hold up to 8 electrons. Okay, they've given us another table, sort of like the one that we were playing around with earlier. Which element has an atomic number of 12? That would be magnesium. If the atomic number is 12, it must have 12 protons. The number of electrons is going to be equal. And so how many electrons would it have in the outer shell? Well, we're going to take those 12. We're going to start filling them in the innermost ring. So 2 of the 12 are going to go there. We come out to the next one. We still have 10 electrons to place, but this shell can only hold 8, which means we need the third shell. That third shell is going to have those final 2 electrons. So the number of electrons in the outer shell is just going to be 2. Now, the other thing that I want to mention at that point, and I don't think they do it anywhere in here, is the electrons that are in the outer shell are also called valence electrons. Those are the electrons that are going to determine the reactivity of an element. In other words, how is it going to react or interact with another element that comes nearby? The other ones that are in the earlier or in the innermost orbitals, they don't participate in the reactions as much. And so really it's just the ones in the outer shell that matter. The other thing that I want to mention is there's a shortcut to figuring out how many electrons are going to be in the outer shell that's present on most periodic tables. If you look at the periodic tables, there's Roman numerals above each one of what's known as a group. This is group 1, this is group 2. We're going to ignore the transition metals. This is group 3, group 4, group 5, group 6, group 7, and group 8. So if you look at just the Roman numeral that goes above it, that Roman numeral is actually telling you how many valence electrons an atom has. So magnesium is in group 2. It has 2 valence electrons, and that's exactly what we got off over here. So if you really understand the periodic table, instead of having to draw it out and do your math in your head, you can just look at which group it's in. The only element that would lie to you about is little helium off over here. It's in group 8, but it can't have 8 electrons. It just has 2. Everything else follows that rule though. So Moving right along, carbon has an atomic number of 6, which means it's going to have 6 protons and 6 electrons. How many are going to be in the outer shell? 2 of the 6 are going to be in the inner shell, which means we've got 4 more to place. So 4. Just to show you again, carbon, it's in group 4. Number 17 on the periodic table, that is chlorine. 17 protons, 17 electrons. From here on out, I'm going to just do the shortcut. Chlorine is in group 7, so it has 7 valence electrons. Number 11 is sodium. It has 11 protons, 11 electrons. It's in group 1. Number 7 is nitrogen. Has 7 protons, 7 electrons, and it's in group 5. And so that is something that takes some practice to get used to. You can always check your work to see if you're right by drawing stuff out, or if you're drawing stuff out and want to check your work, you can come back to look to see what group it's in. It's a way for you to verify you're right before submitting anything on any of the quizzes or tests that we give you. After that, they start talking about models, and like the announcement says, I doubt any of you have balls and springs at home to play with these models, so you don't have to worry about that page. You can cross it off. Hopefully this helps you get through all those worksheets though.